Let's start with the integration by substitution. We'll start with the substitution. To fix the substitution to give me one of these easy integration I already know, right? This is our aim in the substitution for right now, okay? Fine, okay. Let's start. If we have a question asking us to find the integration of these functions. Find the integration, this is number 1, x plus 4 to the power 5 dx. So I don't have this one in this table, right? But I have something similar to this one, x to the power n dx. Even if it is y to the power n dy, it will be y n plus 1 over n plus 1 plus the constant of the integration. So my aim is just to change the question into one like this. It doesn't matter x or y or z. So the substitution will be what? The substitution, you let x plus 4 equal to something else, y, z, whatever you like. I call it y. So this substitution will change everything in terms of x into y, right? So, okay, so I will replace x by x plus 4 by y. What about dx? To find dx, I have to differentiate y. Okay, so if you differentiate y, you have dy by dx equal to what? The derivative of x is what? Is 1. The derivative of 4 is 0 because it is constant, right? Now, dy will equal to, when I'm multiplying like that, dx. So dy is equal to dx. What happened now? My integration, x plus 4 to the power 5 dx will become the integration of, instead of x plus 4, it will be y. So y to the power 4. Instead of dx, I have dx equal to dy. Now I can use this formula, right? You will tell me this is x, it doesn't matter, x or y. But once you have y to the power n, you should have dy over here. To add 1 to the power and divide it by the new power plus the constant of the integration. Of course, n shouldn't be in -1, just to make the denominator equal to 0. Okay. Now I know this one, I have to add 1 and divide it by the new power plus the constant. I'm saying all the time, substitution is like a bridge. Okay. So once you finish, you get back to the, you can go back to your original variable, right? So y is what? X plus 4 to the power 5, yeah, over 5 plus c. Okay. Let's go for another one. If you have a question, find the integration of 1 over 1 minus 2x dx. Do we have 1 over 1 minus 2x dx in our table here? If not, do we have one similar to this one? I think so, yes. I have 1 over x dx. The integration of this one is the logarithm of the absolute value of x, just in case x is negative, and we don't accept the negative value for the log function. So the log of negative value doesn't exist. Okay. Plus the constant of the integration. So if I replace what I have in my question into something else, I call it y or z or whatever, I can use this formula, right? So 1 over y dy will equal to log absolute value of y plus c. 1 over z dz is exactly log the absolute value of z. 1 over theta d theta will be, the integration will be log the absolute value of theta plus c. Whatever the value here, you should have the derivative of it, right? Now, yes, I will change this time and I will let z equal to 1 minus 2x. This is my substitution. So everything will be changed into terms of z. Okay, so the integration 1 over 1 minus 2x dx will be, yes, will be the integration of 1 over z. What about dx? I have to differentiate z with respect to x to know what is dx. The derivative of 1 is 0. The derivative of minus 2x is minus 2. So I need, so when I multiply, I have do z equal to minus 2 dx. I need only dx, so I have to divide it by minus 2. So 1 over minus 2 dz will equal to dx. So now I can get rid of the dx, and instead I'm writing my 1 over minus 2, 1 over minus 2 dz. Any constant, you take it outside the integration. Now I'm ready to use this formula. 1 over z dz will be, the integration of this one will be logarithm of the absolute value of z plus c. Okay, so it will be equal to 1 over minus 2 log the absolute value of z plus c. Now I pass the bridge, I will get back to my original variable, which is x. So z, it will be replaced in terms of x. So log the absolute value of 1 minus 2x plus c. Fine. So I'm looking for the table and I'm looking for the substitution to give me one of the ready-made integration in the table. Let's go for another example. Find the integration of e 3x minus 2 dx. I don't have it in my table, but what I have the integration of e to the x dx. So even if I have e to the y dy, I will have e to the y plus c. So I can get rid of 3x minus 2 and make the substitution 3x minus 2 by something else. I call it y, z, theta, whatever. Okay? I call it y. Fine. So the integration of e to the 3x minus 2 dx will be what? Yes, will be the integration of e, and instead of 3x minus 2, I will replace it by y. What about dx? So I have to differentiate dy by dx. dy by dx is equal to the derivative of 3x, which is 3, and the derivative of minus 2 is 0. So no need to write it down. Okay. Now what I need dx. So I will get dy over 3 dy will equal to 3 dx. I'm looking for dx. So dx will equal to what? 1 over 3 dy. So also I can replace dx by, yes, 1 over 3 dy. Any constant, you take it outside. So take the 1 over 3 outside. So you have the integration of ey dy. Now I am ready to use 1 over y dy, and I will have the result of this integration as a log absolute value of y plus c. So this is 1 over 3 e to the y plus c. Once you pass the bridge of the substitution, get back everything into the normal one. Y, I take it by 3x minus 2 plus c. Yes, it is easy when I know what the right substitution I should do. Let's go for this one. The integration of cosine 3x plus 4 dx. When I'm looking at the table, I have the integration of cosine only. The integration of cosine, whatever the angle is, and I have the derivative of the angle, I should have sine of the same angle plus c. Call it x, call it y, call it z. So if I got cosine z, I should have dz to have the integration as sine z plus c. Okay, so I know I have to get rid of this one as a substitution. So I will let y equal to 3x plus 4. Up to this substitution, my integration for the cosine 3x plus 4 dx will become what? Will become the integration of cosine y. What about dx? To have dx, I have to differentiate this one. So I have dy by dx equal to the derivative of 3x is 3. The derivative of 4 is 0. Okay, so no need to write it down. So I have dy by dx at this one. I'm looking for dx. So dy will equal to what? 3 dx. I'm looking for dx only. So dx I divided by 3 dy. Now I have dx. Now substitute here, so you have 1 over 3 dy. What about the result? You just take this constant outside. Any constant multiplied, you can take it outside the integration. So the integration of cosine y dy. And I know from the table, this will be sine y plus c. Y is not my original variable in the integration, so I have to get back everything to the normal one. So instead of y, I get it as my substitution was 3x plus 4 plus c. Yes, let's go for the fifth one. If I am asking you to find the integration of what? Of 2x root square of 1 plus x squared. Don't worry. Dx. What's your problem? Your problem will be the 2x or the thing under the root square. Okay. Before I think about this one, I think about this is equal to what? 2x, and this is the root square is exactly the power half. Okay. So I have no problem with this one, but I have a problem with this one. So what am I supposed to do? Yes, I'm supposed to do the substitution by something down the root square. Okay, so the problem was the thing under the root square. So how to solve it? I will let y equal to 1 plus x squared. That's fine. So my integration of 2x root square of 1 plus x squared dx will become what? The integration of what? I will keep this 2x as it is. Root square of what? 1 plus x squared is what? Is y. What about dx? I should think about dx by differentiating y. When I'm differentiating y, dy by dx, I should have the derivative of 1 is 0. The derivative of 2x squared, I get the 2 down and subtracting 1 as I used to do in the derivative. Now, I'm looking for dx. So dy will equal to 2x dx. I'm lucky because I have 2x dx. I have it here. So I will get rid of this one and substitute it by dy, right? So the integration of 2x root square of 1 plus x squared dx will equal to what? Will equal to this 2 piece is just dy. And this one will be the root square. 1 plus x squared is y. So if I make the root square as y to the power half, I can use what? I can use this one. Y to the power n dy will equal to y to the n plus 1 over n plus 1. Whatever z or theta t, but you should have the derivative of your variable here to add 1 to the power and divided by the new power plus the constant of the integration. So I will add 1 to the half. So I have 1 plus half, it will be 3 half over the new power plus c. Now I finish the substitution. I know y is my substitution to be what? 1 plus x squared to the 3 over 2 over 3 over 2 plus c. This is the integration. I make it very simple when I know what is the right substitution. Okay, let's have another one. If you have been asked to find the integration of 4x over the root square of 2x squared plus 1 dx. What is the right substitution? I always have a problem with this one, right? Okay, so this is the one I have to get it as a substitution. So I will let 2x squared plus 1 as y. Fine. So the integration of 4x over root square of 2x squared plus 1 dx will equal to the integration, the root square of 2x squared plus 1 is y, so I write it y here. So I need to find dx. How to find dx? I have to differentiate this one. Dy by dx equal to the derivative of 2x squared is what? Is 4x. And the derivative of 1 is 0, so that's it. So dy will equal to 4x dx. Yes, this one, 4x dx is here. 4x dx is here. So this is what? This is dy. Now, I know the root square of y is y to the power half. I can get this one up and make it, the power will be with the opposite sign. Because I know 1 over x to the power n is x to the minus n. Okay. Now I can use this formula, but for y, not for x. So I will add 1 to the minus half, so it will be half over the new power plus c. Now I finish the integration and get back to my original variable. So it will be x to the power half over half plus c. X to the power half, it is better to write it root square x plus c. And this half, when you divide it by half, is exactly like multiplying by 2. So this is the right integration. Let's go further to have this one. Find the integration of sine root square x over root square x dx. How to solve this one? I'm looking for the table to give me clue. When I look at this one, I know how to integrate only sine. So what? I have to have it only sine something. So what can I do? I have to have it sine y, sine x. So I have to get rid of this one by the substitution. So I will let y equal to the root square of x. Okay. So my integration for the sine root square x over root square x dx will become what? Will become the integration of sine y. What about dx? To find dx, I have to differentiate this one. So dy by dx would equal to what? It is better to go for root square x as half. So now it is easy to find dy by dx. Dy by dx will be what? How to differentiate this one? You get the power down and subtracting 1 from the power, 1 minus half minus 1 will be minus 1. Okay. Now, x to the minus half, it is better to get it down. When you get it down, you have it to the positive half. X to the positive half will be exactly what? Root square x. Okay. Now I'm looking only for dy by dx is equal to 1 over this one. So dy will equal to what? 1 over 2 root square x dx. Now I have dx over root square x, but I don't have this 2. So what am I supposed to do? I get the 2 with the dy. So I have 2 dy will equal to 1 over root square x dx. Now I am ready to have this one as, yes, as dy. But I have to take the 2 outside because dx over root square x is 2 dy, right? Now, what is the integration of sine? It is minus cosine. Why it is minus cosine? Because when I'm integrating sine, I will have minus cosine x. Okay? From my table, cosine y plus c. Now I get back everything to normal. Don't miss, 2 will be multiplied by minus, so it will be minus 2 cosine. Y is what? Y is the root square x plus c. Okay. Let's go for Number 8. Find the integration of 2x e to the x squared minus 5 dx. Do you have it in the table x e to the x? No, I don't have. But I have only the integration of e to the x, right? So I have to change, or e to the y dy, or e to the z to z. So I have to substitute something to have this formula. So I have to get rid of x squared minus 5 and make it yz just only variable to the power 1. Okay. So my solution depends on the table. So I will let y equal to x squared minus 5. So the integration will be similar to the one in the table. Okay, so this one will be what? Yes. I will wait a little bit to just substitute by dx as well. So I have to differentiate dy by dx will be the derivative of x squared is 2x. The derivative of 5 is 0. So I need dx, right? So I multiply it here. So dy will equal to 2x dx. I'm lucky. I have 2x dx. Okay. So this one will equal to what? Yes, the integration of e to the y. And instead of 2x dx, I will have dy. Now, yes, I will go to my table. I know the integration of e to the y dy will equal to e to the y plus c. So e to the y plus c. Now I get back to my original. So it will be e, instead of y I have x squared minus 5 plus c. This is a substitution to have one similar to the one in the table, right? Let's go for another one. Cosine x over 1 plus sine x. Okay. Do you have one like this in the table? I don't have. Okay. I don't have. But I have only cosine alone. Fine. So what you have to do? I have to keep the cosine for anything. And we get rid of this one. Okay. So this is the one. Whenever the obstacle for you, you take it as a substitution. So to tackle the problem, you have obstacle at 1 plus sine x. So you let it as y, z, whatever you like as a notation, right? So I would like to have dx. So I have to differentiate this one, dy by dx will equal to what? The derivative of 1 is 0. The derivative of sine is cosine x. Now dy will equal to, and multiply by this one, cosine x. The integration, which was in terms of x, will be transformed into integration of y. Okay, so this is the integration. What about this? Is, sorry, I forgot dx. So cosine x dx is equal to what? Equal to dy. Okay, so straightforward. This one, this piece will be dy. Okay, So this dy over what? Over 1 plus sine. 1 plus sine is what? Is y. Do you have a similar one like this one in your table? I think so. Do you have dy over y or dx over x? I think I have seen it. Yes, I have it. Dx over x or dy over y will be, the integration of this one will be the logarithm of the absolute value of y plus c. Okay. So this one will be logarithm of, yes, will be logarithm of the absolute value of y plus c. Once I finish the integration, I get back to my original variable, which is x, and I know my substitution y is 1 plus sine x, so I have to get back to the x by put x as 1 plus sine x plus c. Okay, I'll do the final one and I'll give you the turn to do some question. This is the final one. Now, the integration of e to the sine x and cosine x dx. Do you have one like this in the table? No, I don't. I have only e to the something here. Only e to the y x dx or dy. Okay, so I have to keep the exponential function alone. So this gives me the clue to have the substitution. It was a very good hint for me to get rid of this one. So I will have this one as a substitution by something y, z, whatever you like, cosine x. And also, I'm not changing only x. I need dx, so I have to differentiate this one. So I have dy by dx. What is the derivative of cosine? It is minus sine x. So dy will equal to minus sine x multiplied by dx. Okay. I'm looking for. So yes, I will get rid of this one, but I have a problem with the dx. So this is the wrong substitution. If I'm thinking about this cosine, I'm not thinking about this cosine. I'm thinking to get rid of this one by y or z or whatever, right? The symbol you are going to use. So my problem is not with the cosine. My problem is with the sine in the exponential function, because here in the table I have e to the x or y. So I don't have sine or cosine in the exponential function integration. Okay, so my problem with the sine x. So I will let the sine x as y. So I substitute sine x by y. I need dx, so I have to differentiate this one. So cosine x. Now dy will equal to what? Yes, cosine x dx. This is the point. Cosine x dx, I have it here, right? But my problem was this one, right? So when you have obstacle, you should have the right substitution to get rid of this obstacle, right? Now, the integration e to the sine x cosine x dx will equal to what? Will equal to e, instead of sine x, I have it as y. Instead of cosine x dx, I have it as dy. Now this is a normal one in the table. The integration of e to the y dy will equal to e to the y plus c. Okay. Now, once you finish, get back to the original stuff. So you will get y and write it as a sine x plus c. I finish my turn. I'll stop recording and I'll give you some exercise to solve. And if you have any question, you can ask.